still. Okay. Solve by completing the square. Okay. Who remembers how we start solving by completing the square?
We get x minus
No.
the first.
Oh, I see what you mean. Yeah, you mean get rid of the 2.
Yeah.
Yeah, so the first thing we have to do is get rid of the 2. So x squared plus 4x minus 6 equals 0. Everybody okay? Now what? Move the 6 over. X squared plus 4x. And I'm going to go ahead and be proactive and leave a little space in here because I know that my next step is to find a special number to fill in. So how do I find that special number? Half of 4 divided by 2, so that would be 2 squared 4. So I'm going to put a 4 on both sides. Please don't forget, this next step is the key. It's the reason we did what we did. This is a perfect square. What perfect square is this? X plus 2. And it equals 10. And then what? Square root both sides. So x plus 2 equals plus or minus square root of 10. Subtract the 2, and there's my answer. Now, keep in mind that sometimes when we do this, that radical can reduce. So for example, it might have been a 12. If it's reducible, if it breaks down, you need to break it down. 10 does not, but it could. That happens, right? All right. Now we're going to simplify. Some of us are still struggling a bit with this, so I am not about, never have been, never will be, about telling you how you have to do it. I'm not telling you how you have to do it. I'm telling you it might be easier if you clean this up first. That's sort of what you're used to just in math life, because don't we do what's inside the parentheses first? So let's just stick with that theme. So when I simplify that, 2 and 3 don't do anything. These are coming down, right? So that'll be x to the 14th. There's 10 people already in your basement. If you bring 4 more down, you got 14. These are going to cancel and leave you with y squared. Everybody okay with that? Now, at this point, I would not distribute the negative. You can. It's absolutely okay to do that. But at this point, I would simply remind myself that when I put a negative exponent on a fraction, it turns the fraction upside down. And I would just turn everything upside down. That's what this negative does. It turns the fraction upside down. Then I'll square everything. So I'll have 9 x to the 28th, 4 y to the 4th. If you force yourself to slow down, Peter, where's your lanyard? If you force yourself to slow down and do one step at a time, I think you'll be fine. All right, write the equation of the line containing these 2 points. Answer in slope-intercept form. Some of you aren't very good at following directions, so it doesn't say you have to use slope-intercept form to do it, but it says when you put something in the answer blank, make sure it's in slope-intercept form. So here are my points. What's the first thing I'm going to do? Find the slope. 10 minus 8 over 1 minus negative 3. Two over 4, 1/2. Everybody good? Now, we need to write the equation of a line. The answer is not 1/2. We need to put that 1/2 into the equation of a line. I'm a point sloper. I'm gonna point slope every time. You don't have to, but y minus 10 equals 1/2 x minus 1. That's how I'm gonna do the problem every time. This would be great if it said answer in point slope, but it says slope intercept. So I'm gonna have to go ahead and distribute and move my 10 over. So if I do it this way, I do have this extra step. What is that, 19 halves? Because this is 20 halves. And this would be the answer to the question.
Do you want us to simplify 19 halves, or?
What do you mean simple? You mean write it as a mixed number?
Yeah.
We don't do, it doesn't matter to me. If you do, it would not be wrong, but there's no need to do it, and you might mess it up. So we're gonna avoid extra steps if we can. All right, number 4. What does AB mean? Distance. Wasn't that on our last quiz, or am I thinking of another class? Yeah. Okay, so distance, here we go. We cannot forget our distance formula. It's part of our math repertoire. So here we go. 5 minus 7, negative 3 minus 2. Do you get square root of 29? Someone nod?
Yeah.
Thank you. All right, and then we've got midpoint. Okay, how do we do midpoint? Exactly, we average them. Eli says, take your x's and add them together. 5 plus 7 divided by 2. So that's 6. And then negative 3 plus 2 divided by 2, what is that? Negative 1/2? Yep. And there's your midpoint. Okay, now we got a couple of scientific notation numbers. You are not going to need a calculator. You are perfectly capable of navigating this. This is a multiplication. Oh yeah, this stays up here. This is Jersey's extra lanyard. And since I'm always the one that watches for it, she wants to have a spare on hand. I've never done that before. It's interesting. All right, here we go. This is multiplication, so the whole thing can be multiplied. So 6 times 2 is 12. And then when I multiply, I add exponents, right? So that would be times 10 to the 4th. Another way of thinking about that is, this is 10 to the 11th over 10 to the 7th. Does it make sense to you? That's 10 to the 4th. Now, what's wrong with this? Because if you put this down, you're not going to get full credit. What is wrong with it?
There should only be like 1 decimal place.
There can only be 1 decimal in front, or 1 digit in front of the decimal place. So this is going to have to move, and that's going to become 1.2. Now, if you remember your left-right rules and all that, you're good to go. I simply remember that I made this part of the number smaller. I went from 12 down to 1.2, and if that gets smaller, this has got to get bigger to maintain balance, same number.
Will it tell us on the quiz to put it in scientific notation, or is that just
Well,
a given?
since the problem was given in scientific notation,
Yeah.
you're gonna answer in scientific notation. All right, what is the slope of a line perpendicular to this one. All right, so this time I'm not writing the equation. This time I'm just finding the slope. So what should I do first? Charlie?
Get y by itself.
Get y by itself. Because getting y by itself puts the equation into slope-intercept form, and then you can see your slope, mx plus b. So this question wants the slope of a line perpendicular to that. So that will be 5/2. If we wanted to be parallel, it would be -2/5. Since we want to be perpendicular, it's the opposite reciprocal, 5/2. Got it? All right, what property is it when we multiply two things and they cancel each other out?
Conjugate.
That's a good idea. That's a good idea. No, it's a very interesting idea. Good guess. The conjugates make the i's cancel out. The conjugates don't necessarily cancel out the whole thing, but they get rid of the i's. What property is this? Meg?
Is it the inverse?
It's absolutely the multiplicative inverse. And you can just write mult inverse, you don't need to worry about spelling out multiplicative, although you can if you want. The inverse properties, remember, cancel each other out. The identities are when you add 0 or times by 1. All right, that's inverse. This would be the additive inverse. This is the additive inverse, right? I did post in Schoology extra property practice any answers, so if you need to do that, do it. Anyhow, that's the quiz. Okay, we all set on that? Everybody knows what the quiz is? We don't take it till Monday, so it's gonna be a while. But you got the answers? And we're all on video. All right, according to my note taking, you just started P7, is that true?
Yeah.
And we're ready just for problem B. So we're thinking about this from a distance standpoint. So let's make sure we take really clear notes here. I'm gonna start with a number, and I'm gonna count forward and backward this far. This is the distance. I want the distance to be 5. All right? The distance between what and what? X and, not 6, -6. Remember, look at what we did yesterday. Yesterday we had this, didn't we? What number did I put in the middle of the number line? 3. Distance is a difference. Gotta be a subtraction problem. Basically, you take the opposite of this. It says -3, but it's really +3. This one says 6, it's really -6. Now, -6 is not the answer. It doesn't even show up in the answer. It's your starting point. This is the distance. I want to be 5 units away from -6. So if I am 5 units away in this direction, where will I be? 5 units this way, -1. 5 units this way, where am I? -11. Now, those two black dots are exactly 5 units away. I wanna be more than 5 units away. So if I wanna be more than 5 away, don't I wanna be out? So my answer is everything from negative infinity to negative 11, parentheses, bracket, because those are closed dots, or negative 1 to infinity. When you're looking at this section of the number line, guys, when you write an interval, you need 2 numbers. So since you're looking at the whole thing, these are your 2 numbers right here, negative infinity and negative 11. And likewise here. The negative 6 does not come into play. The negative 6 is where I start counting, right? And then this is how far I count. What's different about the next one? Huh? Yeah, there's a number out there, and I really don't want the number out there. So any ideas what I might do, Katie?
I just have a question.
Okay.
For a question like this on a test, would, like our work, would it
Nope.
be okay to just do the?
You can do whatever you want to do in terms of work, yep. Yep. I told you yesterday, if you want to go back and do it the way that you have done it in the past, that's perfectly okay with me. My job is to prepare you for calculus, so I'm doing it this way, so at least you've seen this. Next year, you've at least seen it. Whether you choose to do or not, that's up to you. I'm interested in the answer right there. All right, so here's what I'm gonna do now. I'm gonna divide everything by 2. This is 4, is that legal? I don't know legal things. Yes, it is legal.
YouTube says otherwise.
Who said that? Okay, you got me on that one, sure enough. Okay, all right. Now, what's gonna go, what is gonna become my counting point? My beginning point, 1/2. So I'm gonna start at 1/2, and then, that is not an answer. My answer is going to be 3/2 this way, and 3/2 this way. These are my answer numbers. The 1/2 is kind of my base, my home base. Now, what happens if I go 3/2 this way? Where would I be?
2.
I'd be at 4/2, right, which is 2. And if I went 3/2 this way, I would be at negative 2/2 or negative 1. Right, 1/2 minus 3/2. So now, these are the points that are exactly 3/2 away. I want to be less than 3/2 away. So where will those points be? In between. So my answer is negative 1 to 2. Perfect. Perfect, perfect. All right, one more of these. Yep, and then we get some more fun with a different kind of problem. All right, so what do you think I'm gonna do first with this one? If I'm doing it using the number line, what's the first thing I'm gonna do? Divide by 3. So my problem is gonna look like this. Now, where will my home base be this time? Negative 2. And I'm gonna count both ways. These are gonna be my answer points now. These are my answers. I'm gonna count both ways, 1/3. So if I count backwards, 1/3, and I don't care if you use mixed numbers, like say negative 2 1/3, or if you want, think of this as negative 6/3. So if you go back, it's negative 7/3. If you go forward, it's negative 5/3. If you want to say negative 2 1/3 and negative 1 2/3, that's fine, I don't care. All right, they're not closed in this time. Would you agree they're open?
Yes.
And it's a greater than, which tells me I want the distance to be outside more than. So what does my answer look like in an interval? Negative infinity, negative 7/3, parentheses on both, or negative 5/3, positive infinity. I think that way is pretty easy, but if you don't want to do it that way, it's fine. Somehow come up with the answer without a calculator, okay? All right, now, that's number, all those were the same. Now number 2, they kind of all look the same. X squared plus 7x plus 12 is less than 0. Anytime I have a problem that I'm doing by hand, that is no calculator, and it involves an inequality, I'm going to have a number line. Even if you do this a different way, you eventually have to look at it on the number line to figure out what's going on. So now I need to figure out how am I going to get the dots for the number line. You did it over here, you figured out how to get our dots over here. How do you think you might go about getting the dots for this number line? How would I do that? Yes, indeed. Absolutely, you can use the quadratic formula because this is a quadratic equation. So if that's what you want to do, you've got options. If that's what you like, absolutely 100%. If it's an x squared equation, you can always use the quadratic formula. What else could we do? That will always work, and it's fine. Eli?
Could you, solve for the square?
Complete the square? Yeah, if you want to complete the square, you absolutely can. Now, if I'm given a choice, I don't want to complete the square on this one, because why? I gotta take half of 7 and square it, and that's okay, you can do it. I don't want to, because I'm lazy. All right, I got one more option. Katie, you can factor it. And factoring, guys, is always going to be the fastest. It's always gonna be the fastest. But if it doesn't factor, you don't know how to factor it, you don't want to factor, whatever, that's fine. But you've got to find those dots, and the dots will come from the factors. -4, -3. Those are my dots. If you do the quadratic formula or complete the square, you will get the same 2 values. Okay? Now, I gotta figure out where to shade. So I want you to do something for me. I want you to look at your answers to the problems we just did in number 1. And I want you to look at A and C, because they're the less than problems. And I want you to look at B and D, because they're the greater than problems. What do you notice about them? The less than problems are both shaded between, and the greater than problems are shaded out. This is a different kind of problem, but that phenomenon happens whenever you have 2 dots, okay? If you have 2 dots on your number line, no matter what kind of problem it is, you're either gonna shade between them, or you're gonna shade outside of them. You with me? Since this is a less than, I'm gonna shade between them. And my answer is -4 to -3. Think less than. Right? Less than, greater than. Boy, that was easy. Oh, all right, I already wrote my answer. I'm ready to go. Next, what do you want to do with B? I would factor it again. Could I use the quadratic formula or something on this one? I could. Here's the deal. A is 1, B is is 0 and C is negative 16, if you decide to go that route, I'm just gonna factor it. What kind of problem is this? What do we call this? The difference of squares? Make a note if you've forgotten that. Those happen all the time. Right? Did you say soap?
Yeah.
Okay, now, soap is not this.
No, I'm just.
Soap is the
wondering,
difference
yeah.
of cubes. Then we soap. But not with this. This is just x plus 4x minus 4. So I'm going to draw a number line. I'm going to put a dot at negative 4, and I'm going to put a dot at 4. Does that make sense to everybody?
Yep.
Those dots are going to be closed. Now it's a greater than problem. A greater than problem means I'm going to shade out. So my answer, written in integral notation always, will be negative infinity, negative 4. For infinity, should I be using brackets or parentheses?
Bracket.
Well, brackets on the 4s, but always parentheses on the infinities. Right? Oh no! Look at the next one.
Oh, so. So?
No, no. We use soap when we have the difference of cubes. So if we had something like this, we would soap. We don't. We have x cubed minus 4x. Okay, so let's put the soap back on the shelf. We'll get it out when we need it. This is not a soap problem. Any thoughts on this? Okay, I have the same 4 people I've already called on today. I need new blood.
Uh-oh.
What's your thought?
You wanna divide the x, right?
Okay, not divide it, but factor it out. Yep, you're exactly right. It's what we call a GCF, a greatest common factor, and we always want to get it out, whatever it is, whether it's a number or a letter or a combination of both, get it out. Now, what do you notice about this? It's the same thing. It's the difference of squares again. Okay? Now, this problem was a cube. It's our first cube. That means on my number line, there will be 3 dots. Your cubed problem's gonna have 3 dots. How many dots did your squared problem have? 2, always 2. But your cube problem's gonna have 3. Where are the 3 dots? And where are they gonna be here, Dan?
-2, 0, and +2.
Very good. Very good. Now, everybody in the room knew there would be a dot at -2 and +2. But did you remember that a plane X gets a dot, but since there's no number attached to it, it is 0. So these are my 3 dots, they're all open. Now, when there were 2 dots, it was easy. I either shade out or I shade between. Do you see now there's more sections to worry about? There's this section, this one, and this one. So what I want you to do is pick any number that's not a dot. So I don't care what number you pick, but pick an easy one. Don't pick like root 17 or something. Pick something easy. Any number that isn't a dot. Nyla? -3. What is with the negative numbers? Let's pick a positive number. I mean, if you want to use a negative number, I'm all for it, but it's just a hassle.
4.
4. All right, so Eli says 4. Now, this is important. If Nyla sits with -3, she's out here. Eli has picked 4. He's in here. I would have picked 1 because I'm lazy, and that would be in here. Somebody else might pick -1, and that would be in here. it doesn't matter, but pay attention to where your number is. So, Eli's number is here, we're going with 4. 4 is not part of the answer, 4 is just the number I'm checking. So I'm gonna come back to my problem, and either up here or in the factors, wherever it's easier for you, let x be 4 and see what happens. So if I put it in my factors, I have 4 times 6 times 2. 4, 4 plus 2, 4 minus 2. That makes 48. Is 48 bigger than 0? That means that that section of the number line is going to get shaded. Now, Nyla picked -3. Something else is going to happen. It might be shaded, but it might not. If your answer works, and in this problem, positive, greater than 0 means you work. If your number is greater than 0, your answer you get here, then you shade it. Wherever it is, you shade it. Now, I don't know what's going through your mind right now, but are you thinking, oh, geez, Mrs. Ford, now I have to try this and see if this works, and then I have to try one here and see if this works? Yes, that would be the normal way of doing the problem. But I get paid the big bucks to share secrets with you. A secret is that as long as the problem is normal, and I'm going to talk about what's not normal in a minute, but as long as the problem is normal, this is a normal problem, wherever you shade it, it's going to alternate. So since we checked this and it's shaded, this section will not be shaded, and this section will be shaded, and this section will not be shaded. So no matter where you put your number, you're either going to shade it or not, and then all the other sections are going to alternate based on that. So this one's shaded, no, yes, no. And that will be true no matter how many dots you have. So if you have a 4-dot problem, it's going to be the same thing. So my answer will be what? What will my answer be? -2 to 0, or 2 to infinity? Right? Now, 2 quick comments. All the problems we did up to this point had 2 dots. Didn't we either shade like that, or shade like this? Doesn't that alternate? Shade, no, shade? No, yes, no? Yeah. Now, what makes a problem not normal? Well, if you factor it, and you have a factor that occurs more than once, like you have a factor that's squared, then all bets are off, and you have to literally check a number in every section. These do not alternate. These do weird things. So as long as you have separate individual factors, they'll always alternate. Okay? All right, let's try another one. See if you're keeping up with all of this. I'm giving you lots of information. Look at D. What do you think we should do with letter D?
GCF.
What did we do last time?
GCF.
GCF, which is X. Now, this is not the difference of squares, obviously, but does it factor? How? -6, +5. Which means the dots will be at -5 and +6 and 0. Closed in. All right, we kind of flew through that. Anybody have an issue? Is everybody keeping up? So now I gotta figure out where I shade. And you can pick whatever number you want, so Nyla, she wants to pick -7 or something, that's fine. Here, 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 pick any number you want except the dots, you can't pick a dot. So what do you wanna use? 1, I like 1, but if you pick 1, this is the section you're checking. So you're gonna either shade or not shade this section. All right, so 1 minus 5, or 1 minus 6, and 1 plus 5. So I plug 1 in here. You can also plug 1 in here if you want. I got -30. Is -30 less than 0? This is my check right here, less than 0. It is, which means that I shade the area where it is, which means that will not be shaded. This will not be shaded, but this will be. So -infinity, -5, and 0, 6. Answer your question. Why? I'm missing a good one, sorry. Anybody have a question about that? Looks like that's our last cube problem, by hand. All right, let's look at number E, or letter E. This is gonna be a weird one. This is gonna be a non-linear problem. Because how does this factor? Don't I have two factors that are exactly the same? Now, I'm still gonna draw a number line, but I'm only gonna have one dot on the number line. Would you agree with that colored in, one dot? I have no idea how it's shaded, and it will not alternate. So I have to figure out whether to shade this side and or whether to shade this side. Okay? So I'm gonna pick a number over here, any number you want, it's over here. I like 0. So I'll try 0. Now 0 gives me -4 times -4, which is 16. Is 16 less than 0?
No.
So I do not shade that section. All right, pick a number over here, maybe 5. 5 gives me 1 times 1, 5 minus 4, 5 minus 4. Is that less than 0? Wait a minute, is 1 less than 0?
No.
No. Wait, that's not shaded either. So what's the answer to the problem?
No solution.
Don't I have a colored in dot? X equals 4. So the only answer to the problem is x equals 4, because that dot was colored in. Colored in makes it part of the solution.
So if it wasn't colored in, would it be
No solution. Yep. If this had not been here, that dot would be open, and then nothing is shaded, so that would be empty set. All right, one more. What do you want to do with this last one? Then we're gonna get our calculators out. We're gonna fight through one more, try to stay awake. Pretend you're having the time of your life. Okay, here we go. What do you want to do to get started?
Subtract 6.
Get 0.
So,
It wasn't me, it was not me.
All right. Okay, what about this guy now? Meg?
It'd be x minus 3 squared.
Yeah. So this is another problematic situation. We have the same factor twice, and when that happens, whether it's a cube problem, if you ever have two factors that are the same, you are gonna have to do all the work, no shortcuts. So here's my number line, here's 3, open dot. Now, I'm going to pick a number on either side. So I like to pick 0, but you don't have to. Any number less than 3. When I put it in, I get -3 times -3. If I put in 0, that's 9. Is 9 bigger than 0? Shade it. Now maybe I'll put in 4. So 1 times 1, 4 minus 3, 4 minus 3. Is 1 times 1 bigger than 0? Shade it. The answer is not all real numbers. Because why? Because the 3 is not shaded. So I'm going to have to say negative infinity to 3 or 3 to infinity. If this had been an or equal to in the original problem, then that dot would be colored in, and then the answer would be the whole number line, right? To indicate the whole number line, we use this notation, right? That's how we indicate the whole number line. That's not the answer to this problem though, because there's a gap. So we have to write each piece separately. Are we okay? We'll go to our calculators now. And we're going to solve basically the same kinds of problems, but we're going to let our calculator do the work. All squared equations are parabolas. So when we graph this, we're going to see parabolas of some kind. That's what all squared equations are when you graph them. So let's go to Zoom 6. Make sure we have a standard window. Let's go to y equals and clear out any junk we have in there. And then let's put in this equation right here. Is he all right? What's he doing? Eli, what's the matter? Huh? Okay, nobody asked, okay? Sit down. Hurry up. All right, so 4x squared minus 12x plus 7. Hit graph. Did you get a parabola? And it looks like this. Okay, these 2 points right here are where it equals 0. Would you agree with me? So the first thing we have to do is find those points. So we second calc 0, left bound, right bound, yes. Second calc 0, left bound, right bound, yes. All right, let's do that. If you are not sure, second calc 0, ask your neighbor, because your neighbor's probably sure. .79, I'm just gonna go ahead and round off to the nearest hundredth. So I got .79. Tell me if you agree or disagree. Did anybody get .79?
Yes.
And the other one is 2.21 if I round to the 100th. Now, something interesting that has nothing to do with the problem. When I found this 0, my calculator said x was that number and y was 1e negative 12. Have you ever seen anything like that? No? Well, you probably will at some point. Don't worry about it. This is scientific notation for 1 times 10 to the negative 12. Is that a big number or a little number? Very little. That, you can think of that as 0. Just interpret it as 0. If that ever happens to you, it's just 0. Okay. These are the 2 places where this equation actually equals 0. I put open dots there because I'm really not supposed to equal 0, right? But I want to know where the parabola is less than 0. So on your graph, does it make sense that it would be this part right here? That's where it's under the x-axis. So the answer to the problem is parentheses 0.79 to 0.21. That's where it's less than 0. Y is negative. Y is less than 0. Boy, that was pretty easy, wasn't it? Let's look at B. B is set up to do a different way if you want to, but you don't have to. X squared minus 4x greater than 1. If you left it like this, you'd actually put in two equations. You'd put in x squared minus 4x, and then you would put in y equals 1. If you don't want to do that, could we go ahead and subtract the 1 over and do it just like we did that one? Yep. So one way or the other, let's do it. Got to put in new equations, clear out the old. Either put in 1 or 2, depending on how you set your equation or your problem up. I did this one. Did anybody do it with intersections? All right, I'll do it that way too. All right, if you did it with one equation, in other words, you moved the 1 over, you should have gotten a parabola that looked like this. I second calc zeroed and got negative 0.24 and 4.24. Match those, okay? If you set it up as two separate equations, this was y1, this was y2, you got a parabola and a line running through it, and you're looking where they intersect. So second calc intersect, and you get exactly the same two x values. It's the x's we're looking at. Now I went ahead and colored those dots in, and I shouldn't have, should I? Nope. I'm gonna open them up. They shouldn't be colored in. And this time, I want to know if I'm doing this equation, if I'm on this picture, I want to know where the parabola is bigger than 0. So the parabola is bigger than 0 here and here. Would you agree with that? So how do I express that as an answer? Lauren?
Negative infinity, negative 0.24 or 4.24 to infinity.
Very good. This is just like your number line, only instead of heading out straight, it's heading up. If I did it this way, with the two graphs, each side separate, I am looking where the parabola is higher than the line. So wouldn't that be exactly the same two answers if the parabola has to be above the line. Mr. Pisacane, what are you doing? Oh, don't even look at me like that. I don't know what you're doing. Stop it. Okay, so this is the answer no matter how you do it. Okay? Well, I'm gonna stop there. We've packed in a lot of stuff. So I'm gonna stop there. And in our next class, we will finish and start reviewing. So as you plan out your schedule, our next class, whenever that is, we're gonna finish this and start reviewing. The class after that, we'll review, and the class after that, we take our test. All right? So I do not know what day that will be, but we have 2 more classes, and then we have a test. Okay? I'll figure that out. I just can't do it without my calendar and my plan book and everything else.